The 1960s space race was all about national pride. The USA and the USSR battled to be first to the moon. Today the moon is back in the spotlight and there's a new rush to get there. But this time, the game has changed. It's not just about planting a flag, it's about staying there. And the hottest piece of lunar real estate? The moon's south pole. Countries and private companies alike are setting their sights on this region. Why? It all comes down to one crucial resource: water. Water everywhere. The moon's south pole is home to permanently shadowed craters. Inside these craters, scientists believe there are vast reserves of water ice. This isn't just any old ice, it's a game changer. This water can be used for drinking, of course, but that's just the start. It can be split into hydrogen and oxygen. These elements are the building blocks of rocket fuel. This means the moon could become a refueling station for missions deeper into space. NASA is leading the charge with its ambitious Artemis program. Named after the twin sister of Apollo, Artemis represents a new era of lunar exploration. This program is not just about visiting the moon, it's about creating a sustainable presence there. The Artemis program aims to inspire a new generation of scientists, engineers, and explorers. The program's goal is to establish a sustainable presence on the moon, which includes building a lunar base and developing new technologies for living and working on the lunar surface. This base will serve as a hub for scientific research and a stepping stone for future missions to Mars and beyond. The Artemis program is a collaborative effort, involving international partners and commercial companies. Using the moon as a testing ground for future missions to Mars and beyond is a key aspect of the Artemis program. The lessons learned from living and working on the moon will be invaluable for the next giant leap: sending humans to Mars. This involves testing new life support systems, habitats, and other technologies that will be crucial for long-duration space missions. The program has already achieved a significant milestone with the successful launch and return of the Artemis 1 mission. This uncrewed test flight demonstrated the capabilities of the Space Launch System rocket and the Orion spacecraft, paving the way for future crewed missions. The data collected from this mission is being used to refine and improve the systems for the upcoming Artemis 2 mission. The Artemis 1 mission was an uncrewed test flight of the mighty Space Launch System rocket and the Orion spacecraft. It orbited the moon and returned safely to Earth, providing critical data on the performance of the spacecraft and its systems. This mission was a crucial step in ensuring the safety and success of future crewed missions. Artemis II aims to send humans into lunar orbit. This mission will be the first crewed flight of the Space Launch System rocket and the Orion spacecraft. The crew will travel around the moon, testing the spacecraft's systems and capabilities in preparation for future lunar landings. This mission will also provide valuable experience for the astronauts, who will be living and working in deep space for an extended period. While Artemis III is planned to be the first crewed landing since Apollo, this mission will mark a historic return to the lunar surface. The crew will land on the moon, conduct scientific research, and explore the lunar environment. This mission will also test new technologies and systems that will be used for future lunar and Mars missions. This time targeting the South Pole, Artemis III will explore a region of the moon that has never been visited by humans. The lunar South Pole is of particular interest because of its permanently shadowed craters, which may contain water ice. This water ice could be a valuable resource for future lunar missions, providing drinking water, oxygen, and even rocket fuel. The Artemis program is paving the way for a new era of space exploration, with the moon as the first step on a journey to Mars and beyond. China has been steadily building its lunar program with the Chang'e series of robotic missions. These missions have included orbiters, landers, and even a rover. China has made it clear that it intends to send its own astronauts to the moon. Working with Russia, China is planning the International Lunar Research Station, or ILRS. This ambitious project aims to establish a permanent lunar base, potentially near the South Pole. While the timeline is long-term, with the first phase of robotic construction planned for the 2030s, China's commitment to lunar exploration is undeniable. India has emerged as a major player in lunar exploration with its Chandrayaan program. Chandrayaan-1 made history by discovering evidence of water molecules on the moon. While Chandrayaan-2 faced a setback with its lander, its orbiter continues to send valuable data back to Earth. Undeterred, India achieved a remarkable feat with Chandrayaan-3. successfully soft landing near the lunar South Pole, a first for any nation. This achievement underscores India's technological prowess and its commitment to lunar exploration. Section 6. The future is shared. Imagining the first lunar base. The first permanent lunar base is likely to be an international endeavor. Countries from around the world will pool their resources, knowledge, and expertise to make this dream a reality. This collaboration will not only foster a sense of global unity, but also ensure that the best minds are working together to solve the complex challenges of living on the moon. Imagine astronauts from different nations, speaking various languages, all working towards a common goal. This melting pot of cultures and ideas will be a testament to what humanity can achieve when we work together. Governments and private companies will need to work together to overcome the immense challenges of building and sustaining life on the moon. Private companies bring innovation, agility, and new technologies, while governments provide the necessary funding, regulatory support, and long-term vision. This partnership will be crucial in addressing issues such as radiation protection, life support systems, and sustainable energy sources. Engineers and scientists will collaborate to design habitats that can withstand the harsh lunar environment, ensuring the safety and well-being of the inhabitants. This base will likely be built with a modular design, allowing it to expand over time. Modular habitats offer flexibility and scalability, enabling the base to grow as more resources and personnel become available. Each module can serve a specific purpose, such as living quarters, laboratories, or greenhouses for growing food. These interconnected modules will create a self-sustaining ecosystem, where waste is recycled and resources are efficiently utilized. The modular approach also allows for easy replacement or upgrading of individual units, ensuring the base remains up to date with the latest technologies. Initial crews will be small, focusing on scientific research and resource utilization. These pioneers will conduct experiments to understand the moon's resources, such as water ice, which can be used for drinking water, oxygen, and even rocket fuel. They will also study the effects of long-term lunar habitation on the human body, providing valuable data for future missions. The knowledge gained from these early missions will lay the groundwork for larger, more permanent settlements. These initial teams will be the trailblazers, paving the way for future generations to live and work on the moon. As the base grows, it could become a hub for tourism, manufacturing, and even a launch pad for missions deeper into the solar system. Imagine tourists visiting the moon, experiencing the low gravity, and witnessing the Earthrise from the lunar surface. Manufacturing facilities could produce goods using lunar materials, reducing the need to transport supplies from Earth. The base could also serve as a staging point for missions to Mars and beyond, leveraging the moon's lower gravity to make launches more efficient. The possibilities are endless, and the first lunar base will be the stepping stone to humanity's future in space. Section 7. Life on the Moon. What could a base mean for humanity? A lunar base would be more than just an outpost. It would represent a monumental leap for humanity, a tangible foothold on another celestial body. Imagine a thriving community of scientists, engineers, and explorers living and working on the moon, pushing the boundaries of what we know and what we can achieve. It would be a stepping stone for humanity's expansion into space. From the moon, we could launch missions deeper into the solar system with greater ease, using it as a staging ground for journeys to Mars and beyond. The reduced gravity of the moon makes it an ideal launch pad, requiring less energy to escape its surface compared to Earth. The moon could become a place where we test new technologies, conduct groundbreaking scientific research, and develop innovations that could benefit life on Earth. From advanced robotics to new materials, the unique environment of the moon offers a perfect testing ground for technologies that could revolutionize our future, and learn to live sustainably beyond Earth. By experimenting with sustainable living practices such as growing food in lunar greenhouses and recycling air and water, we can develop the skills and technologies needed to support long-term human presence on other planets. The resources available on the moon could fuel a new era of space exploration. The moon is rich in materials like helium-3, which could be used for nuclear fusion, and other minerals that are rare on Earth. By mining these resources, we could support not only lunar operations but also missions to other parts of the solar system, making missions to Mars and beyond more feasible. The moon could serve as a proving ground for the technologies and strategies needed for interplanetary travel, helping us to refine our approaches and increase the chances of success for future missions. A lunar base could also serve as a platform for astronomical observation. The lack of atmosphere on the moon provides a clear, unobstructed view of the cosmos, allowing for more precise and detailed observations than are possible from Earth, offering unparalleled views of the cosmos. From the moon, we could study the universe in ways never before possible, gaining new insights into the origins of the cosmos, the nature of dark matter, and the potential for life on other planets. The moon could become a beacon of human curiosity and ingenuity, a testament to our desire to explore and understand the universe. Section 8. The new space race competition or collaboration. While there's no doubt that there's competition among nations to achieve lunar milestones, there's also a growing spirit of collaboration. The International Space Station has shown that countries can work together towards a common goal in space. The challenges of establishing a permanent human presence on the moon are immense, and cooperation will be key to success. Section 9. A giant leap. The moon as stepping stone to the stars. The race to the moon's south pole is more than just a competition for resources. It's a testament to humanity's enduring spirit of exploration and our desire to push the boundaries of what's possible. The moon, once a distant symbol of mystery, is becoming our next giant leap into the cosmos. The knowledge and experience we gain from living and working on the moon will pave the way for even greater adventures in the vast expanse of space.